right, so good evening, class, and welcome to our performance management class tonight. We will be talking about the assets replacement. Today's class is also going to be a short one too because the topic is about to end. We're talking about capital budgeting replacement theory. Now, we said before that when we are talking about replacing of an asset, we usually talk about replacing an asset that deteriorates over time. That means the asset is substantially of high value, and to get the asset, it has a number of years in which you can use that asset, and it deteriorates over time. We take an example, plant and machinery, which deteriorates as you use them over time. Okay, so we talked about using time value of money and also ignoring time value of money. So we looked at how can we replace this asset that deteriorates, and we use the replacement cycle that is of least cost. So we did something like equivalent annual costs. How did we get the equivalent annual costs? We looked at the present value of each of the cash flow that we got from the assets, and we tried to bring them to we got all the cash flow, right? We got their present value, and we now look at what is the equivalent each year, the cost that is equivalent for each year. And so we use the cost that is lower, the equivalent annual cost that is lower. That was what we used. So we did a decision of whether to replace every year, or to replace every 2 years, or to replace every 3 years, and we choose the one with the lowest cost. Then I gave you illustration 2 as an assignment, which I am yet to get the answer from you. I believe I will get some of your answers. Now, our focus today, our focus today is illustration 3. Sorry, there's a mix-up here. This solution you see here to illustration 2 is actually solution to illustration 3. I will send you a revised material that shows the correct posting. Now, look at illustration 3, which is what we are concerned today. Let's go back to reading the story involved. Now, replacement of assets or components. Now, this is components. Now, we talked about replacement of assets that deteriorates. Now, we're talking about replacement of components that fails suddenly. Now, there's a difference between an asset that deteriorates over time and an asset that fails suddenly. What's the difference? Okay, your plant and machinery gets deteriorated over time, and so the asset as a whole will not be optimally performing over time. But when we talk about an asset that can fail suddenly, or a component that can fail suddenly, let's look at electric bulb. So you just find out that the bulb is shining brightly, and all of a sudden, now notice the word here, all of a sudden, the bulb goes off. It's not shining anymore. So it means that asset has suddenly failed. Okay? Or you have batteries. The battery is working optimally. All of a sudden, now notice that word, all of a sudden, the watch stops. What's the problem? The battery. Or the calculator stops. All of a sudden, that's the battery. Now we're talking about replacing these components when they fail suddenly. Now there are two methods you can use here. We talk about individual replacement. Now, under individual replacement, you simply identify the particular item that has failed and you replace that item. Okay, let's say, for example, your calculator is using 4 batteries. Now, you want to go to the exam and you find out that 2 days to the exam, your calculator stopped working. Took it to where they will fix it, and they said it was because 1 or 2 batteries are bad. So you can either replace that 1 or 2 batteries that are bad, or you do a group replacement. So you can just say, okay, please, I don't want to know how many that has gone bad. Please replace all the batteries. So you usually do that in maybe your remote control or your wall clock. You just say, please replace all the batteries. You don't want to replace the one that failed. Now, these are the things we are going to be looking at. So let's look at 2 examples here. I'll be showing you my Excel notes to show you how these things are being calculated. Let's look at illustration 3. Illustration 3 says, a company runs a production line that contains 50 identical components. Okay, let's be thinking about it like saying that it has 500 identical batteries. Let's look at that. Or let's say light bulbs. These fail on a regular basis according to the following probability distribution. Now, we have the life of the component. For 1 month, there is a probability of 0.2 failure. For 2 months, there is a probability of 0.5 failure. And for 3 months, there's another probability of 0.3 failure. The cost of replacing a single component is 75 naira. So when a single component fails, you replace it with 75 naira. Calculate the cost of replacing failed components. All right, so let me get now to my Excel slide. Now, if you look at this Excel sheet here, this is the solution to question 1. Now, look at the probabilities and the months, month 1, month 2, and month 3, and look at their probability of failure. If you add these probabilities together, you have to add these probabilities together. Let's add them together here. Sum them up to give you 1. That shows you it's 100%. So let me make it 1.00 or 1.0. Fine. That means this must be equal to 1. Now, what is the expected life in months? So it means here that In the first month, probability is 1 multiplied by 0.2, which gives you 0.2. In the second month, we have 2 multiplied by 0.5, which gives you 1. And in the third month, we have 3 multiplied by 0.3, which gives you 9. Now, if you are to add them together, you have 2.1 months expected life, 2.1 months. Now, let's go to the next side. Number of components, identical components, we are told is 500. What is the average expected life is 2.5. That means, what is the number of replacements? So if you are to replace the whole 500 and they have an average expected life of 2.1, it means you are going to have 238 replacements, which means 500 divided by 2.1, approximately 238 replacements. Now, if you are to replace 1, you have to make, each time you're making a replacement of 1, you are making it at 75 naira. Then the cost of individual replacement will simply give you 75 multiplied by 28238. That gives me 17,857 naira 14 kobo. Just say 17,857 naira. So let me make it approximate figure. Okay, 17,857 naira. Now that is the answer for those questions that we were giving here. That's the answer to that question. See it here. It is in solution 2. I'll give you a new replacement for solution 3. Since we are doing replacement theory, I'm going to replace the solution for you. All right, so that's how to answer this question. Now let's go to illustration 4. Now in illustration 4, a company runs a production line that contains 500 components. These fail on a regular basis according to the following probability. And now you are given the same table. Then we are also told that the cost of replacing a single component during a group replacement, now this is group replacement, is 25 naira. And the cost of replacing a failed component is 15 naira. More or less, they are still telling you it is 75 naira, just like this here, 75 naira, but they have given you how it is being distributed, group and components. Calculate the cost associated with different replacement cycles and make a decision. Now, I'll take you back to the Excel. Let's use the Excel to give you the answer. Now, if you look at this Excel sheet here, we have the probabilities, month 1, month 2, month 3. Look at their probabilities, 0.2, 0.5, 0.3. That's fine. Now look at the original component. We have 500. That was what we have, 500. Now, we were told in here that, okay, let me go back to this. If 500 is the original, and in month 1, 20% of it fails. That means 20% of 500, which is 100. Now, if in month 2, 50% of it fails, 50% of 500 is 250. And in month 3, if 30% fails, 30% of 500 is 150. So if you add everything together, it gives you 500. And that's fine. Now, month 1. Okay, month 1 replacement. What does that mean? It means that at the end of month 1, 100 will be replaced. Now, if 100 is being replaced, what is the probability of that 100 being replaced? It's going to be replaced at the end of month 1, which means it will be replaced in month 2. So it means here that 20% of 100 is 200. So 20% of month 1's probability, that is 20%. So 20% of 100 is going to be replaced in month 2. And in month 3, we will still get another 100 still failing. That 50% of 100 will be replaced in month 3 because that is month 2's probability. So you see here, you look at month 1 replacement, which is this 100. 20% of month 1 replacement will be done in month 2, and 50% of month 1 replacement will be done in month 3. If you add them together, you have 70 replacements being done for just month 1 replacement. Then month 2 replacement, we have 250. 250 at the end of month 2, 50% of it will be replaced. So it will be replaced in month 3, which is 125. So when you add the total replacement, gives you 195. 70 plus 125 gives you 195. If you add month 1 replacement, nothing is being replaced during month 1. In month 2, there are 20 replacements, and in month 3, there are 75 replacements. Add them together, it gives you 175. Now, what is the cost of replacing in a group? The cost of replacing in a group is 25 naira. And now it means that if there is a single fault, single failure, we are replacing everything. So it costs you 25 naira each to replace everything, each of the components, 25 naira. So if you want to replace in month 1, we are replacing the whole 500. So 25 naira times 500, because 500 components are being used, you replace them with 12,500. In month 2, if there is a failure, you go ahead and replace the whole 500. And in month 3, you go ahead and you replace the whole 500. Now you will be getting the same figure, 12,500 in month 1 and month 2 and month 3. Now, if there is a failed component, the cost is 50 naira to replace it. Now, in month 1, how many components failed? What failed here is 100 components failed in month 1. And so you multiply 50 by 100, and that gives me 5,000. In month 2, how many components failed? The 100 that failed in month 1, that will be replaced in month 2. 20% of 100 is failing in month 2. So it means here that out of that 100 that failed in month 1, probability is 20%. So you multiply that 20% You multiply that 20% with the 100, and you multiply the month 2 figure of 250 times 25%, times 50%. You add them up together and you multiply it by 50. So what do we mean here? We mean here that, let's do it here. We mean here that month 1, 100 multiplied by 20% is 20. Month 2 is 250 multiplied by 50% is 125. You add them up together, you have 20 plus 125 gives you 145. You multiply 145 by 50 and you have 7,250. That's how we have got that 7,250 that you saw here. So you see, 100%, 100 is failed here. The probability of failure is 20%. So 100 times 0.2 gives you 20. 250 times 0.5 gives you 125. Add them together and you multiply by 50. What did I say about this? I simply use, okay. So now, let's go to year 3. In year 3, or month 3 rather, you'll see month 1 plus month 2 plus month 3. So let's do it together. Month 1, we find out that it's 20. Month 2, we find out it's 125. And so month 3 is going to give us 150 multiplied by 0.3. That gives me 45. If I have to add month 1 with month 2 and month 3, if I have to add them together, I am getting 190. And now if I have to multiply 190 by this 50 naira here, I'm getting 9,500. So that's how we got our 9,500 that you saw in the solution. And so, what is the total cost? The total cost is simply the group replacement plus the individual replacement when there is a failure. So it means here that when we add the 12,500 plus 5,000, we have 17,500. When we have our 12,500 plus 7,250, we had 19,250. And for year 3, we added everything, 12,500 plus 19 plus 9,500, we have 22,000. So now, what is the average replacement cost per month? The average replacement cost per month, since this is year 1, or month 1, sorry, your 17,500 divided by 1 will give you 17,500. For month 2, if you are to make 19,500 for the 2 months, combination, that is cumulatively for the 2 months, you make 19,750 costs. Divided by 2, it gives you 9,875 naira per month. Now, doing the same thing for year 3, you divide 22,000 by 9,500. So 22,000 by 3 months, it gives you 7,333. So which of these replacement circle would you want to do? Will you want to replace after every month, or after every 2 months, or at the end of 3 months? So you replace at the end of 3 months because that will give you the least cost. That will give you the least cost. So this is what we are to do in replacement theory. So that is our lecture for replacement theory. I will send you some questions that you can do on your own. And after that, we'll be talking about, in our next class, we'll be talking about working capital theory. We're talking about working capital management. And this topic will take us from this week down to next week, because working capital is all about your cash, your creditors, your debtors, all the things that make up your working capital. We are going to be seeing how you can manage them. So come prepared next week when working capital management, next class, when working capital management will be our focal point. Thank you so much for the short class we've had now. Please finish the replacement theory. I want you to take your time again to watch this video and to do the exercises that we've treated. If there is anything that you're finding difficult to understand, please call my attention. Thank you once again, and do have a nice day.